Hello everyone, my name is Jingfen Li. My co-author is Dr. Xiao and we're from Syracuse University. Today I'm gonna share our paper, Tree Representations in Transition System for RST Parsing. First, I will walk through our context of our study and I will introduce our approach including the transition-based system, our newly designed labels for multi-branches tree structures. In addition, our refined dependency features. Finally, I'll present our results and conclusions. The transition-based system in the past study proposed a series of actions to build a right-heavy binarized tree for RST parsing. Such binary discourse tree is built over its smallest parsing unit, namely elementary discourse unit (EDU), placed in the leaf nodes. The tree's non-terminal nodes bear the informations of span, nuclearity, and relations. The span is the cover range of a sequence of ADUs, and the nucleotide is the semantic role in the relations, including NS, SN, and NN, where N represents nucleus and S represents satellite. The relations typically includes two types. One is the mononuclear relations, such as the elaborations and explanations. The other is the multinuclear relations, such as the list. Among all the parsing systems dedicated to RST parsing, the transition-based system obtained comparative performance. Initially, all the EDUs are in the queue. The action of shift will shift an EDU to the stack, and the action of reduce will reduce the top two elements in the stack into one span and determine their nuclearity type and relations. Previous study has found that the nuclearity type is an essential feature in detecting relations. However, we discovered when the multi-branches node tree is transformed into a binary tree, it will have the same nuclearity type as the binary branches tree. It would be worthwhile to explore an unique nucleotide type for such multi-branches relations in the original tree. Therefore, we come up with a fourth nucleotide type, the N hat, for the multi-branches relations. In order to capture the distinct tree structures of the multi-nuclear relations, we keep the original RST tree structures instead of the right-heavy binary tree by using the new actions of flat reduce, R hat. As shown in Table 2 in Step 6, the reduce action merged EDU 2 and 3 into one span, while the R hat action maintained the multi-branches structures. We base our study on one's two stages system which achieved the state-of-the-art performance in previous study. And includes the two stages. The first stage is to identify the span nuclearity in the first stage by the joint actions, and we assign the relations in the second stage. We adopt all the features used by one study and two SVMs for action and relation classifier. As shown in Table 3, the frequency of our newly proposed joint action is smaller than the others. To better fit for the sparse training examples, we enrich our features by introducing the dependency features. We refine dependency feature generated by the deep biotheme attention model proposed by Dozet and Mann in 2016. And obtain the representations of hat, dependent, and arc label for each EDU. And we average representations for the spans. As for the experimental setup, we used the 385 documents from the Wall Street Journal, and we detect the 18 color screen relations. We presented results in Table 4 and 5. Compare the first two rows in Table 4. Our refined dependency features improve the performance, and the third row shows that our newly proposed nuclear type is effective, especially in the multi-branches relations detections as shown in Table 5. The multi-DAC system utilized the flag reduced R hat to form the original tree, thus reduced the redundant nodes in the right half of a binary tree and achieved the state-of-the-art performance. So here comes to our conclusions. First, the additional refined dependency features improve the performance in span, nuclearity, and relation detections. Second, we find that the N-hat is effective and distinguished from the binary nucleotype, resulting in better performance on the multi-nuclear relations identifications. Third, the newly designed action R-hat, remaining the original tree structures, helps to prevent from creating the redundant nodes in the right half of a binary tree, thus achieving the state-of-the-art performance. Among other discourse relations, we do not achieve the satisfying results of the relations such as topic change due to the sparsity. Such relations benefits from the global information, so we plan to design a top-down manner system to catch more global informations. That's all for today's presentations. Thank you for watching this video.